You can.
Okay.
I'm a ninja now.
Can you do me a favor and erase the board, somebody?
Not it.
Not it. Rachel's already up to do
There's
it with
an
her hand.
eraser. There's
Lick your hand.
There's an eraser. That's the chalkboard one.
Oh my
Okay,
God.
that's fine. It worked. Can you get that big smudge off the middle there too?
Yeah, Rachel, your hand's so smudgy.
It's still smudgy there.
What was that?
So it's kind of interesting that this is the last section that we will do out of the book. I know you don't have a copy of the book, but out of online. Okay, so it's kind of exciting. We're getting.
Did you say no more Pearson after chapter 12?
This is the last chapter. This is the last section we're doing in Pearson.
So is this technically the hardest thing we're going to learn? Because, like, I can't do it.
I
This is the last thing on Pearson.
think the circles were the hardest.
I can't do this. This is so
You still haven't found your notebook?
What circles?
I can't
Let's
find
work
my
on what's
notebook,
here.
and I
What
went on,
circles?
they said,
Circles, like the warm-up question, but when they get more complicated. All right, so I'm going to give you some tools, and we need to be able to work through and memorize these formulas. Okay, just like the Pythagorean theorem we had to memorize, and now we have it down. Okay, so when I throw a right triangle at you, life's good. If you didn't know it, life wasn't good. That was hard until you memorize it. I have a sheet of formulas. I have them right here that I can't do about any of these problems without my cheat sheet. So, so we have these formulas, and we need to know all of them. Okay, I'm gonna.
They're just a bunch of letters.
Yeah.
So we need to also understand them. So this is the probability. So I actually gave you the formulas today. We're not writing anything down, but this is a test to determine whether something's independent or dependent. Okay. So let me do this. Okay. So this says probability A given B. So B's happen. What's the probability that A is going to happen? So so this is the formula for independent or dependent. But what's going to happen is that the probability that A given B will equal just the probability A if it's independent. Okay, we have to know that. So if I say independent and I show this, you need to know that. Yeah. In that drawer there, there's like 100 of them. Okay. Yes. So given that other things happen. Okay. Okay, so what happens here is if you're independent, if B does not affect A, then that just means that the probability of this happening is just the probability of itself.
That makes almost no sense.
Okay, if I don't affect something, the probability that I will wear green tomorrow, listen please, given that it's going to rain in China, is the probability of me wearing green tomorrow. Because the rain thing in China has nothing to do with my shirt color. Okay, you're asking, so that's how you know if something's independent. If I do this formula up here, and it gives me the same as probability of A, then that means it's independent. It's a test. Okay?
What's the difference?
So if they are different, they're different, then it's dependent. Okay? Okay? Or not independent. If B is affecting A, then it's going to have effect on the probability. If it's not affecting it, it's not going to have an effect on the probability. Also, if I take this formula here and I just kind of rewrite it, and that's all I did down here, is I took the probability and instead of making it divide by B over here, I just times it to the other side. So that's another formula that we may need to use. Okay? So so these three formulas are being added to that long formula sheet we have, and those are all the formulas that we need to know. Yeah.
When you say given that this happens, is it always the second thing that's already happened, or is it?
It's the second thing that's already happened. You want to know what's going to happen in a situation, given that this other thing's happened.
Wait, so is it saying that it's already happened, or that you know it's going to happen, or it might happen? So like,
you want to think, so the chances of it raining tomorrow, okay, and the chance of me wearing green tomorrow, okay? So I get what you're saying. Is it happening? Is it gonna happen? There are probabilities, right?
So like, is it raining right now? Do we see the rain clouds, or is it just a guess, like a 60% chance it's going to rain?
Right, it's a guess. It's all probability, right?
So this whole unit is not guessing.
It's kind of the probability.
That's everything.
When you when you ask, is it going to rain today, and I say 30% chance,
Well, you're not.
that doesn't mean it's going to rain for 30% of the day. It might rain 2 minutes. It might rain not at all, right? It just means probability. Okay. Though we are going to have questions where it's based on something that has happened, and then therefore we can say what the chances of that being. And those are usually the questions where I say, in a building, I randomly pick one student based on what I've already seen, what should happen. That was the question yesterday, the warm-up question, where it was, what are the chances of being born in February? Some of us wanted to say it was 1/12. But it said, given this chart of people, of these people, what is the chances of being born in February? So then you took how many people were born in February and divided by how many people there were.
It wouldn't be like 1/12 because there's also like different amount of days.
So you could get into how many days, you could break it down other ways, but there's situation where I'm talking about this situation, and of these people, what are the chances if I grab one randomly out of the crown box that it's a person born in February? Okay.
Why are people in crown box?
Okay.
How did it fit in the crown box?
So
Like this problem where.
So this problem, these things have already happened, okay? And it says, what is the probability that a member of the art class selected at random is a junior, okay? So we're picking from that, okay. So we want to know the probability that the person's a what?
A junior.
It's a junior. We want to know the probability of a junior given
So would it be 16?
that they are what?
In art.
In art. That's what we're looking for.
So we're only looking at the art column, and then we're gonna take the 16.
So let's figure the formula for this is the probability of a junior and art divided by the probability of art, and it's the second one, right? It's the second. Well, just guys, let me just do it. If you want to think in your head, that's fine. Okay, it's too distracting to everyone else. So the probability of being a junior and in art, okay. So junior is 40, and art is 58. I'm gonna mess this up. Okay, is 100 Adam 138 out of 115 students.
Yeah.
I added these two numbers together. Is that not? Oh my gosh, sorry, 98.
But what about the 16 juniors that are?
Okay,
What do you do with that?
just listen, guys. Divided by the probability of being in art. So how many kids are in art? 58 out of 115. Sorry.
Oh, fraction and a fraction?
Yes. What's really, guys, you can't just start talking. What's really helpful is that the denominator of both fractions is 115. Okay, so I could times this by 115. Don't write this down. Just watch 115 over 115, which is times it by 1. And that's going to make this thing cancel and that thing cancel. So this equals 98 over 58.
Why do we not write that down?
And then this is what you need to write down. I messed this up.
There's over 100% chance.
Yeah. I don't think you're supposed to add them.
Okay. Sorry. Reset. Mr. McConnell struggling. We are all struggling. Sorry. We want the probability of, good thing we write in pencil, right? Okay. Probability of a junior given in art. Okay. And sometimes I got to point out that sometimes it's confusing on what the order is here, but we want to know, is the kid a junior? Yeah, right. So that's the question we're asking. Oh, but also is he in art? So I'm rewriting this probability of J and A, or J and, yeah, over the probability of just A. Okay. Sorry. Thank you for being so patient with me. Tell me a kid that is a junior and is also in art. On this chart, tell me how many kids are juniors and also in art?
16.
16. Out of how many? Out of all of them. This is where I made my mistake.
Wait, I thought the A stands for art. Wouldn't it be 58 though?
Oh.
This is, and then this is just the top. Divided by, what's the probability of being in art? 58 out of 115. So this equals, okay? Now, you're going to probably want to yell at me, okay? Because, let me tell you something. You can do a lot of these just thinking about them without the notation, and the notation might confuse you more than help you, but we have to know the notation. Because what they're going to do is they're going to ask you this question and then just give you this notation, or they're going to make it complicated because it's about the notation. They think that you know how to do the probability. What they don't think what they want you to learn is how to do the notation. So the book says, yes, you could do it this way, but you could also just point out if the question's saying how many juniors, given you're in art, how many people are in art? 58. Out of all the kids in art, how many are juniors? So you could have just said, oh, there are 16 out of 58. What do you notice? Same thing. So let me tell you, if it gives you a question and all you need to do is think through it and you get an answer and it makes sense, I love it. If they're going to throw a notation at you, you got to be able to know how to do that too. Okay. I'm okay with that answer. Okay, so how I would do this, because I don't like to do that simple math in my head, I just want to put in the calculator and let it go. 16 divided by 58,
29.
and then I can hit math, fraction, and it just spits out the answer. Okay.
Do you want us to simplify?
In some ways, I don't care. Okay. I don't care. I think in probability, I care everywhere else. Let's just simplify.
And Pearson, it would care that. So
Okay.
it goes Pearson,
But I noticed on the state exam, this would have been an acceptable answer in probability. But if it was, the length of a side, it would not have been accepted. Okay. So we probably should just simplify. All right. Next problem. Let's see if I can not mess this one up. You guys are being so patient with me. I appreciate it.
Because we're all lost.
When you being realistic or sarcastic?
No, I think you were really patient, and I appreciate it. Yes.
I'm not picking up something. You said 2 plus 2 is 5. We show something, but we don't know how to do this.
Right.
Yeah, you couldn't just like.
Right.
All right, I'm.
Well, good thing I knew I messed up.
It didn't
We'd be
look
really trouble if I didn't even
right.
know. Okay.
It didn't look right because it was over 100%
Right.
chance.
I knew something weird happened. Okay. The table below shows the vehicle in the parking lot one afternoon. You're seeing me struggle, right? You're seeing me work. This is what I expect. I said that answer's not right, so I tried again. Okay. Anyways, a vehicle in the garage will be selected at random. So this has already kind of happened, that these cars are already there, and I'm reaching down and I'm just grabbing one randomly. Okay, that's what that means. Let B represent a black vehicle and V represent a van. Are the events B and V independent or dependent? Okay, so that's where the test comes in. The test is that the probability of B given V, okay, the question is asking, does that equal the probability of B? That's what the question's asking. Now, this is where it gets kind of weird. We're going to use the formula for this one and just figure out what this one is on its own, okay? So the formula for this says the probability of B and V divided by the probability of V of the second.
Divided by the second one.
It's of the second, because out of those, what are the two that we have? Okay, and then this one we're just going to figure out on its own. So what is the probability of being black? 13 out of 22. Okay, so the percentage of being black vehicle is 13 out of 22. Because right here, 13 are black out of the total 22.
Okay, I was looking at the actual cars.
Doesn't this just make sense to say like it's independent because like it doesn't
So we got to run the test. Okay, whether you think it's independent or dependent, you might not. It may not be super clear.
Why can't we just do like, you know how last time we took the total and then the other total, why can't we do like 3 divided by 13 and then like.
Okay, so he's saying a black and a van. Black in a van is 3 out of, no,
3 out of
3.
22 out of all of them.
Why is it out of 22?
Out of the total.
Out of the total.
3 black vans. There's 3 of those.
Okay, that's what this is, divided by probability of just being a van.
3 out of 22.
3 out of 22.
Oh, yeah.
So what does that equal?
1.
1.
How's it going?
Well, 0.1.
So I kind of wrote it bad, but 3 out of 22 over 3 out of 22. What does that
I mean,
equal?
it's 100% chance because
So that's 1. It's 100% chance.
because all of the vans are black.
So what was the question asking?
Or the dependent or independent?
So what is it?
They're
It's
Independent.
independent because
You
it
could
can be,
buy-
it can be both.
Oh, it's dependent.
You could buy a
Since-
car
since,
whether
Since the B, the black van and the D are the only cars you can get.
But
So this,
black it isn't a van.
so here's the question. Are those equal?
no.
So not equal means what? Not dependent, or no, dependent. Not equal means dependent.
I told you guys.
So why couldn't?
Because, stop, pause. So what it's saying here is V is affecting whether it's black or not. If you pull out a van out of the lot, is it going to affect what color it is?
Yeah, because there's only
Yeah,
one color.
it's going to affect it.
Wait,
So in this situation, it's dependent. So not equal. Independent would be that these two things equal each other, meaning that the probability of B is not affected by this V in there at all. That this and crossing this out are the same thing. Okay? So this is dependent. The V affects the situation.
It's just buy any color band now?
No, we're not talking about any color van. We're talking about this parking lot. If I say go grab a van,
There's only black van.
you're going to come back with a black van. That van, grabbing a van is affected. Okay?
But it's the exact same thing, so why wouldn't, if it's all of them?
If I say grab a van, is it going to affect what color it is?
Yes.
Absolutely. You're going to come back with a black van.
If you wrote it the other way, it was V. V.
So you're allowed to, Jonathan has a very good point. We could have tested this, the probability of V given B, and asked, is that the same as the probability of, what would we put here? V. So the question is it being black affecting that it's a van? If these are equal, okay, which they shouldn't be, because this is the same question. Okay.
So,
Basically,
but
independent events mean that if there's two things or more, they do not affect the things at all, like the degree difference and the rain in China, and then this part is completely affecting like the outcomes of the country.
It's dependent because of the situation. If I put other colored vans in there, it might become independent. Okay. So if I say I want to wear a blue shirt, but I have numbers on them, okay, then it might, and it's a situation, right? Because we know all vans are not black, but in this parking lot, all vans are black. Okay. I have a feeling that if we tested pickups, because each one's a different color, that they might be independent. Okay. So good point. So if I change this to be what here, 2, then I bet when we do this test, it's going to be independent because it doesn't matter what pickup you get, you're going to get a different color. The color is not going to be affected by the car.
So to get independent, you have to have all the numbers the same.
Right. And this is how we prove whether it's independent or dependent. It's just simply by doing this. So I love the fact that we're surprised, because I can tell we're surprised that the color of the van matters. Okay, right? Because you would think it doesn't matter. How is the color of the van matter that it's a van? Well, in this situation, it matters.
Okay, so why, you said that you can do it backwards,
Yeah.
right?
Mm-hmm.
How come it's?
You want me to do it backwards?
Yeah,
So P, V given B.
yeah.
Question is, does that equal the probability of a van? So probability of a van.
In the first question, you said the second letter is what is the.
Yeah, the second letter, so wouldn't it be the probability that it's black?
If it's independent
It
or
has to-
independent.
it is black, but what's the probability of the being?
So the first question, it was a different formula.
No, in the very first.
This is the very first question. Boom. Right here.
Right here. This
That is the same formula.
Okay.
Yeah, but it isn't asking if it's dependent or independent. It's asking
Then
for
why
the
don't we use the
probability.
formula to?
Okay, pause. So we use this to figure out what this is.
Figure out, well, what is?
The probability.
The probability of J given A.
Yeah.
This question over here is asking, is it independent or not? So then I use the formula, is the probability of V given B equal to P? That's different.
So that you put the
That's
first
the
letter
exact
first.
same.
You put, so like last time it was the second letter, never mind.
So look, the first one, I use this formula.
The
Okay.
second one, you still use
The
that
second-
formula.
One, I use this formula, and in order to figure out what this is,
You have to use that one.
I use the other formula. But in the first one, I did not use this formula because it didn't ask me if it was independent or not. Did I ever ask whether it was equal to just the probability of A?
I don't know.
Okay. So, do you want me to run through this here, the probability of B given B, the other way? I'm going to do it super quick. So it's the
None of us understand it. Like,
it's the probability. Okay, this right here is going to be that formula that says, so this, I'm going to give me that formula that says probability of V and B out of the probability of B, of the second. And this one I just have to figure out. What's the probability of being a van?
Probably being a van is 3 out of 22.
3 out of 22. Okay, that's still the same. And I'm not expecting this to equal 1 like it did last time. I just need to show that it doesn't equal this. Okay, so the van and black is what? 3 out of 13. No, 3 out of 22. Okay,
then probably black.
divided by the probability of black is
3 out of
3 out of
3 out of 13.
No, there's a lot more black.
13 out of 22. Okay, and that simplifies down to 3/13. So all this question is asking is this equal to this? If it's not equal, that means it is dependent. It's affecting it. Okay? If I do something and it doesn't affect me, then it's independent of me. It's outside of my life, right? There's a car accident in Chicago, Illinois. I didn't even know it happened. Okay? It doesn't bother me at all, right? So that doesn't change me. It's not, it doesn't affect me. Okay?
So dependent means that it's affected, that the event is affecting the probability while.
Right. So it's going to change our outcome. It's going to affect it. If I'm in a car accident, okay,
That's definitely dependent.
I'm using the language wrong, aren't I?
It's definitely
I don't know.
Wait a second, if you get to know car accident, who would teach geometry?
Not you.
I would teach from the hospital.
You do online course.
We're sitting here Skyping with Mr. McConnell sitting 30-degree errors and scrapes all over his face. Teaching us how to do the 13 probability.
The probability of get it, if you grab a van that's constantly black, aren't those related?
Yes.
Showing the monitor right now, I'm putting it down.
Dependent because it affects it. It depends on it.
I can imagine
So
just
why
watching
would having an equal number of different colors of cars be independent?
Because no matter if I said go grab a van and you say which color, it's going to matter. It's not going to matter, right? You're going to have the same chances of getting that color. But if I say go grab a van, we also have the. All right, so as much as I tell you, I don't like percentages. You do not want to mess with percentages when it comes to probability, because when you multiply percentages, weird things happen, okay? So just for example, if I did 70 times 80%, okay, what is 70% times 80% equal?
7 times 20.
If you don't do it like that, then you get this, and it confuses me. The answer to that is 56%. Okay, so 80% times 70% times 80% is 56%. So I don't want you messing with percentages because it gets confusing. I'd rather just say, let's talk about them in terms of decimals. So right here off the bat, I'm going to say 0.7, I'm going to say 0.8, I'm going to say 0.3, I'm going to say 0.25. Okay, that's how I'm going to work with them. And life will be a little easier. And if you ever get a probability over 1, you made a mistake. Okay?
Wait, hold on. Great. Probability over 1.
Yes. You can't have probability over 1. 1 is 100%.
So why is it?
So you can't have probability of 200%. Okay?
I mean,
But what if you like a 0.2 over 1?
So in these problems, they're never going to have an answer that's over 100%.
probability of that event.
And is that the same for like the state test? Oh, wait.
I agree, whether she believes it or not.
Wait, do you have negative probability?
I don't think so.
Well, I just said one.
Yes.
You're wrong.
The problem, like, if it was impossible, then the probability would be 0, which means
Yeah.
it cannot possibly.
Yes, thank
So
you.
if you need to go and do it.
All right, we got to get through this. A band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that the surveyed student planned to attend the band's concert is a fan? Okay, so we want to know what? Oh, and is a fan. Okay, so the probability of attending and is a fan. Okay. Well, you might go with your friends or whatever.
I think you actually just solved this question.
Is that 80% of 70, I mean, 0.8 of 7?
Well, I don't know. Let's look at the formulas. The formulas are going to help us through this. Okay. So the formula that I'm going to use, I think, on this one is.
No, because of the ad, because there's, it's
The first one?
Is this one.
I think you literally just did this and solved it.
Because if you get a 50,
Oh, wait, no, no, no.
Okay, pause. Just let me do it, guys. Okay. So the formula that I'm using says it's the probability of A given F times the probability of F. Thank you. So that's the formula that I'm going to try to use. I have no idea if it's going to work. I'm throwing something at it, and I'll tell you that if I had a probability problem that I didn't know how to solve, all I would do is just start throwing different formulas at it until it made sense. That's what I expect you guys to do.
But I don't know what it makes sense. Because,
If you get over 100%,
yeah, but what if it's like 4 different answers of like make sense answers, and which one do you go with?
okay.
You go with the
I don't know.
Yeah.
Okay.
No, I don't know. Take the right answer.
I don't know.
Okay, so what is the probability of attending given that you are a fan?
So the probability of
80%.
attending is 0.7 over 100, or like 70%.
Okay, so up here, plan on attending who are fans. So right here, they're giving it to us as 80%.
It's 0.8 of the 0.7.
Exactly.
Because it says of the students who plan to attend, and 70% or 0.7 plan to attend. So 0.8 of that 0.7 are fans.
Yeah.
So it's
Yeah.
really 56%.
So,
So it's 0.8
Yeah.
times 0.7.
It's
so
56.
that's 56%.
0.7 times 0.8.
Yeah, it's
Yeah.
56%.
And you get a book there, and they have it on 50% off, so it's not gonna be free. Sorry, I have to use books.
Books.
I can't even work.
Mr.
I wish it was
Ronald,
flipped around. I like 0.7.
Why can't the answer just be 0.8, since it's asking the probability of the fan and a fan of, like a,
Right, because it, Paul, because of this.
yeah.
So that's crazy confusing to me as well, that this, why isn't this and? Because, and the reason is that this is not and, this right here is the probability that you are, stop talking, please, goodness. Okay, probability that you plan on attending and you're a fan. So this is a fan given that you are attending. So those are different things, but they seem really similar.
So I think we're doing the question wrong, because it says, so pretty much it's saying it surveys all students, and it says, what is the probability that any one student that is surveyed is a fan and also plans to attend? Because it also gives you the students who do not plan to attend. So it's pretty much thinking of the group as a whole, and so it's thinking this out of this. So pretty much it's the whole, and out of that whole, which of these students plan to attend and are fans.
Okay. So we're going to move on. Okay. Go ahead. Ask your question.
So if you do 0.7 divided by 10, because 0.8 is 8/10 of 0.7, and then you multiply the 0.7 divided by 10 times 8, you get 0.56. So could we have just done that in the first place?
Maybe. Okay. We're going to go on to the last question here. It's probably 0.56. We're going to move on, and we're going to come back to it. I know. I'm sorry. You guys are so patient with me. We're going to jump down to these two questions. Okay. So only one group got these right yesterday. So I want to talk about what happened, and the groups that got it wrong got the same wrong answer. So we gotta have to kind of figure out what's going on there. So here.
Good for you guys.
So you have to know these formulas. Now on this, you guys can't talk one because I can't think and discipline at the same time. Okay. So you have to figure out what the situation's, what's happening from the formulas, and then go from here. Who felt like they had a really strong handle on this first one?
I actually understand it.
Okay, go to the board and, well, sort of, you scared me. You got it really strong?
I just need the thingy from the formula sheet because I don't actually have it.
Okay.
Yeah, nobody feels strongly on it.
I don't feel strongly.
Do you
Does that make you feel any better?
No.
You're supposed to do you have like teach us to be semi-strong.
Filled out. No, I don't.
Does somebody have this like mark like 10 seconds? Yeah, you have good news. Thank you. Yes, thank you. Okay. So it's the thing you were not also, yeah, that's it. So you do.
So the question you got to first ask, is it mutually exclusive or not? Okay.
Well then, is it or not? I don't know that part.
Okay, so let me take a stab at it. Watch me sweat. Soccer skin. Okay. Hope you can sit down. Thank you for willing. Okay, so I'm looking at my formula sheet, and first I'm going to figure out if it's exclusive or non-exclusive. Okay, so right here I have this formula, okay, or this formula. So I'm going to first test to see that this is the OR language. Does this plus this equal that? Okay.
So it's not mutually exclusive.
Okay. So then look, if it does, listen, if it doesn't, then it's this formula here. So watch, this formula says, but listen, guys, stop talking. Probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So this is the formula that I'm going to throw at it and see what happens. I can find the unknown if there's just one. Well, the probability of A or B is 49 over 80. Yeah. Equals, do we know what the probability of A is?
Yes, we do.
We-
It's 7/20.
7 over 20.
Figure out what the probability of A or B was.
It's all given right here. And what's the probability of B? It's given right there. Minus, this is what we're looking for. I'm going to not write that ugly thing. I'm just going to put an X there. Can I do that?
Sure, why not? Let's do this.
14 20.
So X is the answer.
So X is the answer. That's what I'm looking for. So all I got to do here now is go 49 divided by 80. And then I'm going to subtract 7 divided by 20. And I'm just going to do that twice. And I get this as my answer, math fraction. I did something wrong, didn't I?
It's 7/80.
49 over 80.
Minus 14.
Thank you. Minus 14 over 20. What did?
This is I know how to do it.
14 over 20 is both of them.
Oh, duh. So then I get negative point, well, and then math fraction gives me negative 7 over 80
Negative.
equals negative x. So x equals,
How do we get 780?
Because of what we just did.
Calculator.
What did we just do? Think about it.
so I'll tell you what, you just throw it in formulas, and if it worked, do you feel like that worked? We got an answer.
How do we know if I got an answer?
It didn't work.
Okay, so let's see if we can use that same formula here. Now it says not B. Okay, so we're going to have to be careful. We're going to find B
Would not be.
and then do the not version of it.
I know how to do that.
So I'm going to rewrite the same formula.
What's a not be?
Yeah.
We'll talk about it in just a second.
Isn't the probability of not B happening just the probability of A happening? So 11/20 is?
No.
No.
Just give me a second. Okay, so I'm going to figure out what we got here. I'm going to plug in what I can. Okay, and so I have or is 28 or 283 over 400. I have 11 over 20. I don't know what that is. I'm going to go ahead and call that X for now. And then minus 77 over 400.
What about that's 283 over 20?
I put it over here.
Oh, yeah, hold on.
Okay.
So I just called it B. I'm going to solve for the probability of B.
You subtracted A and B, but you don't know what B is, so why'd you name it 77 over 4?
Because this says, this is the formula, probably,
Yeah.
which is just given to us. Okay, so 283 divided by 400. Okay, and I'm going to subtract this and add this to that number. So it's minus 11 over 20 plus 77 over 400. And I get that X equals 30.35. Or I could change it to math fraction 7 over 20.
7 over what?
Over 20. 7/20. So the probability of B, if the probability of B is 7 out of 20, then the probability of not B is 13 out of 20.
Watch your language, Mark.
My bad.
Complement. Anyone know what complement means?
When you say something nice about somebody.
No.
So the complement is not, so if I could ask this exact same question and ask you, what's the complement of B? Complement of B is not B.
What the heck?
So complement means not that. So why is it called complement? Because together they equal what?
1.
1. So complement means the other thing that would add up to make it 1.
So what was the word that we used during proofs that added up to 180?
Supplementary.
Why can't we just use that?
Complementary is 90.
That'd be more sense.
Okay? So that's complement.
Why do they use the word compliment so much?
90. Yeah, I know that.
So I want to point out to you on your quiz, okay? Don't get wrapped up in like some of these questions on the top as far as how to solve them. All they want you to do is tell if it's independent or dependent. I'm going to give you questions that are more complicated and ask if they're independent or dependent without you having to solve them. So all you got to do is think through whether does that affect the other thing. So the color of my shirt, raining in China, independent. The color of the shirt, me pulling it out of my closet, that's going to affect it. Okay? So like that. Also, replacement, non-replacement is words we use a lot. So non-replacement means it's dependent, means it affects it. They love to ask the question, if I eat it, you better not put it back. Okay? So that's dependent. So a lot, and then here, these are pretty straightforward. I think you can do them without formulas. But then they're going to start throwing out all these formulas at us. Okay? Also, because we don't have enough to do.
Excuse me, what do we need to do?
Please don't add Pearson. Please.
That's always Pearson.
Oh, are you gonna add, because you're gonna add all these formulas to quizzes?
Yes.
Oh,
I
this is
mean, that's the
homework.
only way I know anything to do with
Yes,
this.
I have homework.
Now, listen, this is important. The code, so that 975748, Jackson's on there too, I think. We got to beat them. But after you play the game once, okay, as soon as you finish the game, there's a flashcard version. You can hit the flashcard and you can study. You can study them and then retake it. That probably makes more sense to do that flashcard thing a bunch and then retake it and knock it out. Okay? I took it twice last night and I did not get 100%. I need to study more. I know. We're in the same boat. You don't like being in my boat, do you?
No.
I mean,
No.
it's kind of, I like being in a better boat.
What?
We like living dogs.
I think we're gonna join Jackson's boat. I think they understand this.
We do not need to be on like.
Can I get another copy of
So, what would I write?